What if everything you know about the universe is just the beginning of the story? Most of us learn about the Big Bang, that the universe exploded from a single, unimaginably hot and dense point and has been expanding ever since. It's backed by mountains of evidence: the cosmic microwave background, the motion of galaxies, the very structure of space itself. But here's the twist. The Big Bang doesn't tell us how it actually happened. It shows us the aftermath, the fireworks, not the spark, and that's where things get wild. In this video, we're going to explore some of the boldest, most mind-blowing theories about how the universe could have truly begun, ideas that challenge everything you think you know about reality. Next, let's take a moment to stretch your mind even further. What if there was never a before the universe at all? Not because we lack answers, but because time itself, the very fabric that allows before and after to exist, was born alongside the universe. Asking what happened before the Big Bang is like asking what's north of the North Pole. The question simply doesn't make sense because time, as we understand it, didn't exist. To wrap your mind around this, imagine time as a river. Right now, it flows steadily from the past toward the future, carrying events along like a current carrying leaves and branches. But at the moment of the Big Bang, or the first expansion of space-time, the river itself begins. There's no upstream, no source. The flow starts there. There's no before for the river, only the flow itself. Without space and time, before and after are meaningless concepts. Asking about a time before time is like trying to imagine a color beyond the visible spectrum. Our brains simply weren't built to comprehend it. And yet that river, time, is intimately linked with space. According to Einstein's general relativity, space and time are part of a single dynamic fabric, space-time. When the universe was compressed to a near singularity at the beginning of the Big Bang, space and time themselves were compressed to their limits. There was no ticking clock, no moving planets, no cause and effect chain. Everything that allows events to happen, movement, change, even entropy, didn't exist. The universe was an undifferentiated state, a kind of cosmic potential waiting to unfold. Think of it like a blank canvas that not only holds no painting but doesn't even exist yet. The moment the universe begins, the canvas appears, the paint is ready, and time starts its inexorable march. Without that canvas, there is no frame, no reference, no before. And that's the truly strange and wonderful implication. The universe doesn't need a prior cause in time because time itself is part of the universe. The question of what caused it may be fundamentally unanswerable in the terms we normally use because causality itself is a property of time. Here's an analogy to make it a little more human scale. Imagine a book that doesn't have a first page. It's not that the first page is missing. It literally cannot exist because the concept of a page only makes sense within the context of a book. Time is like those pages. It only exists once the universe exists. There's no preface to the book because the book, the universe, is what creates the possibility of a preface. Mind-bending, right? Some physicists extend this even further. If the universe and time itself emerge from a quantum state, then the beginning is not a moment in time but a state of potentiality. In this state, all possibilities coexist, and the laws of physics operate not in time but in a timeless, mathematical landscape of probabilities. In other words, the universe could emerge spontaneously, without a ticking clock, and yet follow precise rules. The beginning is not an event. It's a transition from timeless potential into temporal reality. And here's where it gets really fun to think about. If there was no before, then the universe may not be bound by the kind of linear history we're used to. Maybe time is more like a coordinate system that starts at zero at the Big Bang, but the underlying principles, the laws of physics, exist independently of it. Gravity, electromagnetism, quantum rules, they may have existed as timeless structures along with space and time themselves, long before energy, matter, or motion came into being. This opens the door to the wild idea that the universe isn't just ancient, it's potentially infinite. Even if time and energy started at the Big Bang, the framework that allows the universe to exist may have existed forever. Imagine the implications. Every particle, every photon, every galaxy could be seen as a consequence of these timeless laws in the fabric of space-time, which existed before the universe had energy to fill it. The universe doesn't just begin at one moment. It is the unfolding of eternal rules into a temporal dance. Our very existence is a witness to laws that have no beginning and no end. That flips the way we think about history. There may never have been a first second, and yet we exist now. We are literally inside the first tick of a clock that started with energy and matter, but the canvas on which that clock ticks may have been laid down long before, in the timeless expanse of space and the laws that govern it. Let's play a mind experiment. Picture yourself standing at the edge of a vast cliff, looking out into a void. You want to know what's beyond, but the void is infinite. There is no beyond, because the concept itself relies on something finite to reference. That's what before the universe is like. There is no outside, no prior space, no prior time. There is only what begins when the universe begins, and everything flows from there. The Big Bang is not a point in time. It is the emergence of energy and matter within pre-existing space, time, and laws. And yet, it doesn't leave us helpless. If energy and matter started with the universe, then we can see the universe itself as a kind of proof of timeless structure. The fact that the universe obeys laws consistently, that particles behave predictably, that stars form and die according to rules, it hints at something deeper, something eternal. Space, time, and the laws that govern everything may have existed forever, waiting for energy to enter the picture and the universe to begin. So the next time you think about beginnings, remember this. There may have never been a before, but that doesn't mean the universe was created out of chaos. Instead, it could be the first manifestation of energy within a pre-existing, timeless framework of space, time, and laws. The Big Bang is not just an explosion of matter and energy. It's the birth of the universe as we experience it, emerging into a cosmos where the rules and the stage were already eternal. It's an idea that flips everything on its head. The universe isn't simply old. It's a bridge from the eternal into the temporal. And it makes you wonder, if energy can emerge into pre-existing space, time, and laws, what other impossible things in the cosmos might just be natural? What structures, rules, or realities exist beyond energy, waiting to unfold? And if the stage existed long before energy, could the universe itself truly be infinite? Not just in space, but in its potential to exist again and again. And if space, time, and the fundamental laws of physics could exist before energy itself, then suddenly the universe popping into existence isn't just possible, it starts to make perfect sense. This brings us to one of the coolest, most mind-bending theories out there, the zero-energy universe hypothesis, sometimes called the zero-sum energy theory. At its core, it's the idea that the universe could have come from nothing, because the total energy of everything, matter, light, motion, might perfectly cancel out the energy of gravity. In other words, the cosmic ledger could balance at zero, and existence wouldn't require any payment at all. Imagine this. The entire universe, the stars, the galaxies, the planets, even you, might have cost absolutely nothing. Zero. Nada. No energy, no cosmic bank account deficit. Sounds insane, right? But this is exactly what some physicists mean when they talk about the zero-energy universe hypothesis. At its core, it's the idea that the universe's positive energy, everything we normally think of as stuff, is perfectly balanced by negative energy, mostly gravity. Matter, light, kinetic energy, radiation, all of these count as positive energy. But gravity? Gravity is weird. It's like nature's checkbook balancing system. The energy of gravitational attraction is negative. Pull two massive objects together, and the potential energy of that system is less than zero. Now here's the wild part. If you add up all the positive energy and all the negative energy in the universe, they might cancel out exactly. Total cosmic sum, zero. A perfectly balanced equation. And if that's true, then the universe could literally have popped into existence out of nothing. Not something from nothing in some poetic sense, but literally, mathematically, energetically nothing. Think of it like a simple analogy. Imagine you're walking on a perfectly flat, frictionless tightrope. 1 foot forward, 1 foot back. Step left, counter it with a step right. You're moving, but overall, you're not really going anywhere. That's the universe. All the energy moving and swirling, but the cosmic ledger stays balanced at zero. Physicists love this idea because it solves a major question. Why does something exist at all? If the total energy is zero, the universe doesn't need a source. It doesn't need a cosmic spark or a creator to pay the bill. The universe could simply emerge spontaneously, and it wouldn't break any physical laws. But how could this actually happen? Here's where it gets even cooler. Quantum mechanics allows for temporary violations of energy conservation at tiny scales. Particles pop in and out of existence all the time in what's called quantum fluctuations. Normally, these events are microscopic and vanish almost instantly. But the zero-energy universe hypothesis suggests that, on a grand scale, the same principle could allow an entire universe to appear from nothing. Gravity's negative energy makes it energetically neutral, so the universe can expand and exist without borrowing energy from anywhere. Mind-blowing, right? To make it more concrete, imagine writing a check for $1 billion, but at the same time depositing $1 billion in another account. Your net balance? Zero. That's how the universe's positive energy in matter and radiation might cancel exactly with the negative energy of gravity. And if the sum is zero, existence itself becomes possible without violating any laws of physics. Some thought experiments push it even further. Picture a universe forming as a bubble inside a vacuum of nothingness. This bubble has mass, light, and motion. Everything you'd expect in our universe, but the energy of its gravitational field is negative, so the bubble is energetically balanced. Inflation, a rapid expansion that happened in the earliest moments, could then stretch this bubble into the vast cosmos we see today. One reason physicists take this seriously is because it elegantly explains why the universe doesn't require infinite energy to exist. If the cosmos started with zero net energy, it can keep expanding, forming stars, galaxies, and planets, all without violating conservation laws. It also meshes with general relativity and quantum field theory, giving it a strong theoretical backbone. Here's a mind-expanding way to think about it. Everything you see, the Milky Way, your body, the photons bouncing around your room, could be the plus side of the energy equation. Gravity, which binds galaxies and stars together, is the minus. Together, they sum to zero. The universe isn't a debt, it's a cosmic balance sheet. And that balance might explain how something as massive and complex as reality can spring from nothing at all. So next time you look up at the night sky, think about this. The whole universe, billions of galaxies, each with billions of stars, might have been free. Literally. And the reason it exists could be as simple as cosmic bookkeeping. The zero-energy universe hypothesis isn't just physics. It's like discovering that reality itself is nature's ultimate magic trick. Next, we're diving into another mind-bending idea, the cyclic or bouncing universe. Imagine if the universe didn't just start once, but has been reborn countless times, expanding, contracting, collapsing, and then bouncing back again. In other words, what we see today might not be the beginning at all, but just the latest chapter in an eternal cosmic story. At the heart of this theory is a simple, almost poetic concept. The universe expands, as we know it is doing now, but gravity and other forces eventually slow things down. The expansion reaches a peak, then reverses. Everything, the galaxies, stars, planets, contracts inward. Space itself compresses. And then at some extreme point, instead of ending in a final big crunch, the universe rebounds or bounces, and a new expansion begins. This cycle could repeat infinitely, like a cosmic heartbeat. So how could this actually happen? The physics is wild but fascinating. One idea involves something called dark energy and quantum gravity. Right now, dark energy is pushing the universe apart, causing accelerated expansion. But some models suggest dark energy might change over time. When expansion slows or reverses, gravity and quantum effects at extremely high densities could prevent a total collapse. Instead of crushing into a singularity, the universe could bounce, smoothing itself out and starting fresh. Think of it like a cosmic trampoline. The universe compresses, then springs back. Here's a thought experiment to picture it. Imagine a rubber ball being squished down. The more you compress it, the more it wants to rebound. The bounce releases energy, reshapes the ball, and sends it flying again. Now replace the ball with everything in existence, space, time, energy, matter, and you get the idea of a bouncing universe. Each bounce could reset conditions, creating new galaxies, new stars, maybe even new laws of physics slightly tweaked each cycle. One of the mind-blowing implications of this theory is that the universe could be infinitely old. If cycles have been repeating forever, then the Big Bang we think of as the beginning might just be the latest bounce. There could have been countless universes before ours, each with its own expansion, contraction, and rebound. And that changes how we think about history itself. The story of the cosmos might not have a starting point. It might be eternal, rhythmic, like a cosmic drumbeat that stretches beyond imagination. Evidence? Well, this is where things get fascinating. Some features of the universe hint at pre-Big Bang cycles. The cosmic microwave background, the faint glow left over from the Big Bang, shows patterns and fluctuations that some scientists argue could be remnants of previous cycles. Certain models of quantum gravity, including loop quantum cosmology, naturally lead to bounces instead of singular beginnings. And mathematically, some cyclic models can explain why the universe appears so flat and uniform today, similar to what inflation does, but through repeated resets instead of one rapid expansion. Imagine the implications for everything we thought we knew. If the universe has bounced before, then maybe time itself has a rhythm beyond human comprehension. Every star we see could be a product of countless cosmic histories. Every galaxy, every particle, might carry the echoes of previous universes. And maybe, just maybe, the universe is still carrying the memory of all its past lives in ways we haven't yet fully decoded. So the next time you look at the night sky, think about this. Maybe the universe isn't just 13.8 billion years old. It could be as old as existence itself, cycling through endless expansions and contractions, each bounce giving birth to new possibilities, new matter, new stars, and maybe even new versions of reality itself. The cyclic universe isn't just a theory, it's like nature's ultimate reset button on the cosmos, and it makes you wonder what happened before our Big Bang and what will come after. And with that, we'll leave it here for now. The universe is full of possibilities, some we've explored today, and countless others still waiting in the dark. If you enjoyed this journey, consider subscribing. It's one of the best ways to support these videos and helps me keep making them with the depth and quality they deserve. And I'd love to hear from you. Leave a comment with the theories or hypotheses you'd like to see explored next. Who knows? Your idea might become the spark for the next deep dive.